So today we're going to discuss a concept in calculus called first principles. And to break it down, what I'm going to do is I'm going to start with the goal of calculus. So the goal of calculus is to find the derivative. So what is the derivative? So the derivative is actually the slope. It is the slope at any point on a function. The slope at any point on a function. Now, the function, right, is a curve, and to find the slope at any point, what you do is you draw a tangent to that point. So let's say you have a parabola, and this is completely, it just represents some general parabola that opens up, let's say, although it doesn't have to, and I've got a point right there, okay? So I want to find the slope at that point, meaning if I draw a tangent to that point, I want to find the slope of that tangent, right? Now, what does that have to do with first principles? Well, first principles is an equation that looks like this. Actually, I should write it like this: x plus h minus x, and limit as h approaches 0. So this is a limit expression. So if you've already done limits in calculus, this limit expression shouldn't be a complete shock. But let me break this down for you. So right here are actually two x values. So x2 in this context is some x value here plus h. And you don't know what h is, but h is some value, right? And I'm going to call h the horizontal distance. And x by itself without the h is called x1. So this looks very similar to a regular slope calculation, where over here you've got y2, and over here you've got y1, and on the bottom you got x2 minus x1. So this is just a slope calculation. Now what is it? What is first principles the slope calculation of? Well, it's actually the following. Let's say you've got 2 points on a parabola. Let's say this is x1 and f of x1. And over here, you've got x2, f of x2. Now, let's call h the horizontal distance between the 2 points, meaning h is this distance right here, the x distance. What if I made that h really small? Meaning, what if I took h and I made it approach 0? What would happen to these 2 points? Well, the 2 points would actually approach one another. The 2 points would actually become 1. And that is the very definition of a tangent. You see, if I draw a line to these 2 points right now, I would call that line between those 2 points the secant line. But as the 2 points approach each other, that line goes from being a secant to a tangent. So if you were to then calculate the slope of that line, it would eventually become, as h approaches 0, the slope of the tangent, which is the derivative. So that's the whole point of doing this calculation. So if I perform this calculation right here, I'm actually getting the derivative. Okay? Now let's do that now. Let's pick a general function, let's pick a specific function and actually perform this limit calculation. You have to do a bit of algebra. So let's say f of x is equal to x squared. Well, this means f of x plus h is equal to x plus h squared. And if you perform some expansion on that, you'll know that it's x squared plus 2xh plus h squared. Okay, this is just using FOIL, right? Now all I've done is I've evaluated this expression right here, and this is already a given. So I'm just kind of assembling the two, the quantities in my actual limit. So if I actually write this out right here, and I plug in my information, this is what happens. Watch this. So let's plug in my information. What do I get? This becomes lim as h approaches 0 of x squared plus 2xh plus h squared minus, and this thing right here is x squared, so I'm going to go minus x squared all over. And if you notice, you can actually simplify the bottom readily. The x's cancel, and all you're left with is h on the bottom. Now what does that become? Well, the x squares actually cancel. And remember, when you're doing a first principles calculation, there should be stuff that cancels. If it doesn't, then you made a mistake. You should get cancellations. Now, what's left in my actual expression? Well, I've got 2xh plus h squared over h. What can I cancel out of this? Well, in each term on the top, if you notice I've got two terms in the top, it's a binomial, I can actually cancel a factor of h because there's a factor of h in the bottom. So I can cancel this h, and I can cancel one of the two h's here with that h on the bottom. So what am I left with here? I'm left with an expression as h approaches 0 of 2x plus h. Now if you make h equal to 0, what happens? Well, all I'm left with is 2x. Ladies and gentlemen, the derivative of this function, f of x equal to x squared, is 2x. What does this mean? This means that if I take any x value I want on that parabola, for example x equals 2, and I plug it in, I will get the slope at x equals 2. So for example, if x is 2, the slope at x equals 2 is 4. If I take x equals 3, the slope at x equals 3 is 2 times 3, which is 6. That is the first principles calculation. All I'm doing is I'm doing some algebra with limits to determine the derivative as a function at any point on that original curve. Okay? So this is basically essentially the goal of calculus, is to get the derivative. Now, if you notice, this involves a lot of algebra, and pretty soon what we're going to be discussing are some derivative rules. Some rules that you can apply so that you can avoid first principles in doing this long algebraic calculation. Now, I've done this first principles calculation for a very simple function, f of x equal to x2, but I could have used a much more complicated function. And so what we do later on is we use these rules in order to use these shortcuts to get to our derivative faster. Okay, so all we're doing here is we're using limits, stuff we've already learned, to determine the slope at any point on a function, and using that we've basically gotten to our goal. We've achieved our goal in calculus. So if you found this video enlightening, please leave a like, comment, subscribe, and I'll see you in the next one. Peace. Bye.